Now, the complex number z is given by this, so we already know this is the modulus is r and ei theta. You're given that this is in the first quadrant, 90 degrees ma. This is quadrant 1. Okay, this modulus of course because if this is not positive, then you need to consider when it's negative, but positive means this is definitely a modulus. Modulus z is actually equals to r. Okay, in case you forgotten, I say that when it comes to complex numbers, right, when you see the ratio of 1 to 1 and 1 to root 3, okay, this you can find the exact argument. Okay, the reason being is because we have the special angles for these two ratio here. So it's very standard one. When you see in A level, right, you see this is 1 and root 3, 1 to 1, or 2 to 2 root 3, or 2 to 1 or 2 over root 3, and so on. The ratio here tells you that you can find the exact argument. Okay, so that's about it. Actually, for the first part, it's pretty straightforward. If you want to find the modulus w, so w is given by 1 minus root 3 multiplied by z, right? Okay, so if you want to find mod w, so modulus w will just be modulus 1 minus I root 3 z. So this one modulus will just be 1 minus I root 3 multiplied by mod z. Okay, so when you modulus both, you can just modulus the first one times the modulus of the second one. Then this case here, the first one is quite straightforward. This is just root 3 square plus 1 square. Mod z is just r. Okay, this is mod z. So there you go, this is r. So this is 4, so this is 2r. So what do you want to find? We just want to find z, right? In terms of mod z, in terms of r. Okay, so found this already. Then the argument of w. Remember, argument behaves like logarithm, exactly like log. It is exactly like log. So this case here, ln a b will be ln a plus ln b. So likewise, this will be argument 1 minus root 3 plus argument z. Okay, so this one I think you already know lah, so it's not an issue. 1 minus root 3, draw it out. The argument of 1 minus root 3 would be 1 here, minus root 3 is here. So 1 minus root 3 will be this argument here, which is minus pi over 3. Okay, some of you may have issue, so if you have issue, you just draw it out. So this case here will just be minus pi over 3 plus argument z, which is theta, right? Theta. Do I need to check whether it is within the I don't think so. Yeah, I don't think, because theta minus pi over 3, you just minus pi over 3 throughout, minus pi over 3 half. I just want to see whether it's within the principal angle. Minus 1/3, I think is 1 over 6 out. 1 over 6. So theta minus pi over 3 is actually still in the principal angle range, so you don't need to worry about it. So if this is not in the principal angle range, then you need to plus minus 2 pi. Okay, you need to do that. So for part 3, given the argument z10 and over w2 is pi, what you need to do is actually just argument it, and then you just z to about 10. Like I say, argument behaves like logarithm. So this is a pretty okay question, I think. z10 over w square is equal to pi. So this case will be argument z10 minus argument w square equals to pi. This is 10 argument z minus 2 argument w equals to pi. Argument z is what? Argument z is actually theta. That's what we want to find, right? Find theta, right? So 10 theta minus argument w we already found. Argument w was this one here. Theta minus pi over 3 equals to pi. Okay. There you go. You get the idea. I don't think is like rocket science here. So we have got 8 theta plus 2 third pi equals to pi. This will be 1 third pi, 8 theta. So theta is actually just divided by 8, so it's 24 pi. Okay. I think it's pretty okay.